so it will be continuous if our denominator is not equal to 0. So anytime we have a fraction, continuous if the denominator, t squared plus 5t plus 6, is not equal to 0. All right, so to solve that equation, you could bust it out into the quadratic formula, but the easiest thing to do will be to factor it. So we think about the factors of the first times the last. So 1 times 6, we need two numbers that multiply together to give us 6, and they need to add to give us, these two lovely numbers need to add to give us 5. So you think about it, and maybe like 3 times 2, that will give you your 6. 3 plus 2 will give you your 5. Now, because you do have a 1t squared, you can just plop these numbers down. So you can write this as t plus 3 and t plus 2. Now remember, we don't want those little numbers, okay? So we do not want those two factors to be equal to 0. So what we do is we set t plus 3 not equal to 0, t plus 2 not equal to 0. We get t is not equal to negative 3, and t cannot be equal to negative 2. So our conclusion here is this function is continuous provided that t is not equal to negative 3 or negative 2. Now, of course, the question is what type of discontinuity happens at those two numbers. So to answer that question, because we have a fraction, we want to answer if we can remove those denominators that are causing the 0. So if you go back to your function, you had t plus 3 over, and then the denominator was this t squared plus 5t plus 6, which we went through factoring to get this. So I'm going to plug in that factorization. And now once I have it factored, I then can say that the division is going to be undone with multiplication, and I can cross out this t plus 3. Now, when I remove, quote unquote, cross out that t plus 3, that is a removable discontinuity. So we have that at t is equal to negative 3, there will be a removable discontinuity. And remember, a removable discontinuity is really just a hole that we talked about in pre-calculus. Now, meanwhile, the denominator of t plus 2 was not removed. So our non-removable discontinuities, what's left over is going to be the t plus 2 factor. So we set that equal to 0, we get negative 2. And so that tells us that the non-removable discontinuity is at t is equal to negative 2. Now, do keep in mind that this particular textbook refers to it as an infinite discontinuity, and that is because it is a vertical asymptote. So we have a hole at negative 3, that's removable discontinuity, and then we have a vertical asymptote at negative 2, which is an infinite discontinuity.